Our next guest is somebody that I met on a ski slope. And he asked me, what was it that I do? And I said to him, well, actually, I'm a physician and I work in the mountains. I guess I'm called a mountain medic. And he promptly says, that's a bit like a molehill medic, just a bit different. And from then on, all he's ever done is introduce me to very important people as a molehill medic. Since then, I've had the pleasure of working with him on a number of projects and talking about life, the universe, and everything. He's tried to teach me about N equals P or something like that.
Or not.
Or not, as the case may be.
Yeah.
And the emergent properties of biological systems simulated in silico, and right through to whether gefitinib or ifatinib will work better on a particular type of cancer. So we've covered quite a lot of things. And we've done this in a wonderful variety of places, which I shall never forget. It's been a great privilege to have spent the last 5 years getting to know Stefan. And I think we should just recognize that really he is one of the most disruptive minds in innovation and one of the most brilliant entrepreneurs that you'll meet. I guess he really is, for me, an odds beater, a rule breaker, and a Berlin Wall basher. And it gives me a great pleasure. And please give a round of applause to Stefan Roever.
Thank you. It's a pleasure to be here today.
Let's see if this works. Have we got the slides? Well, hey, okay. This, Stefan, is a picture I found of you. I can see you there crouching down in a very attractive brown jacket on the right-hand side, bashing the Berlin Wall. This is my first question to you, is what on earth were you doing here, and how is this a kind of an inspirational picture which depicts the rest of your Berlin entrepreneurial life?
Yeah, that's actually a picture my daughter found on the internet when she was asked in her history class to do a report on the fall of the Berlin Wall. And when the wall came down, I was in Germany at the time, and my best friend from college, the guy next to me in the black jacket, pulling the blonde girl over the wall, we were at a party together, and I heard the news on the radio that the wall's coming down, and I said to Heino, we got to be there. This is only going to happen once. So we got to be there, and we got to see what we can do. So we climbed on the wall, and we started helping some people over. And over the years, I've bored my family to death with stories of this Berlin Wall weekend. But this was in the days before cell phone, and we didn't have a camera, and we needed a little portable transistor radio to figure out what was going on where. And I don't really think my family believed that this thing actually happened. But my daughter went on the internet, and she started searching for these pictures, and she found the picture and says, Dad, is that you? And I say, yeah, that's me. And then her next question was, why are you wearing white socks? Okay. So, well, you don't really understand. That was the time. And I wish, this is actually an AP photo, a stock photo that's now been used in quite a lot of articles. And I wish they had photoshopped the white socks out there.
I don't know, there's probably some AI that could do it for you now. So tell us about Berlin, tell us about Brocat, tell us about the backlash and your kind of views on governance and Big Brother.
Yeah, so this was obviously in the late 80s and early 90s. I was in college in Germany studying law and economics. Also always had a bit of a mathematical inclination. At that time, that was sort of the early days of the internet. And what transpired was that the US had export restrictions on strong encryption. So you couldn't export SSL-enabled browsers that are essentially the backbone. If you want to do secure commerce on the internet today, everything's SSL encrypted. At the time, that was considered a military secret, so you couldn't export it. And that really annoyed the hell out of me. I felt that this is sort of a privacy, freedom of expression right, and I also felt it shouldn't be that hard to reverse engineer that technology. So I founded a technology company called Brocat, and I was still in college, and we basically built a encryption algorithm that could run in a standard browser, so you didn't have to download any software. It was built using a Java technology. And we started selling it to banks, Lloyd's in London, Deutsche Bank, et cetera. And it became a runaway success. About 2,000 banks worldwide started using it. And at some point, I kind of thought, look, I don't really want to be a lawyer. I think this is a lot more interesting. I started doing that company full-time. We took it public, and we started getting a lot of heat from the US government. So they tried to shut us down. There was a Senate inquiry on this. President Clinton had his advisory commission. Ultimately, I got invited onto that. I was on several panels with Secretary Daley, the Commerce Secretary. And I said to him on a panel like this, I said, Secretary Daley, we're a public company. I said, it's the $5-6 billion market cap that we had at the time. That's legitimately value that should have accrued to the Netscape shareholders, because if it hadn't been for your export restrictions, Netscape would have gotten these deals, right? And we wouldn't even be in business. Of course, he didn't like that. And we got a lot of good press out of that. But what happened is we ultimately, together with a few other companies, but I think we were one of the key driving factors, forced the US to change those laws, right? And they were pushing very hard to do other things, like put backdoor technology into Intel chips, et cetera. And there was basically, based on this, a huge backlash. And that's the technology today that's really the backbone of the sort of the crypto revolution we're seeing, right? And our view at the time was, this is a basic human right. This is freedom of expression. Everybody should have access to these technologies. But the lesson learned was, if you want to change the policy, the best way to do it is to make that policy unenforceable, right? Basically, just build the technology that basically makes it policy ineffective, right? And that's exactly, we can get back to that later, but that's what a lot of these crypto companies are doing today, right? They are putting technology out there that cannot be regulated, and as a libertarian, that's something I very much like.
So the first startup that I saw you be involved with was Genia. And when I was in your offices at the time, it was a pretty garage-based startup. Here's something that I found. This is your crew in pretty basic premises. And of course, it turned into something very German and shiny, or Swiss. There we go. Turned into Genia chip, which you successfully exited to Roche in 2017. And this is like an incredible example to me. The story and seeing that unfold, beating the odds, coming back from the brink of death from a business perspective, is something you're pretty good at doing. Tell us about the story, and also a little bit about how you would advise other entrepreneurs in terms of beating the odds, because you seem to be terribly good at doing that.
Yeah, so I got involved. I moved to the US. We did an IPO on NASDAQ for Brocat. I moved out to California. I thought I was only going to be there a year or two. It's been 18 years now. And I went to Starbucks one day on Sand Hill Road, where all the VCs are. And I'd read an article in Scientific American the night before on the origins of life, like how did life evolve on Earth at the molecular level. And there's a guy in front of me that's reading a book on exactly that same topic by the author that wrote this article, right? And so I talked to him and say, hey, I just read something on that. What are you reading there? We get talking, and it turns out he's developing a DNA sequencing technology in his garage. DNA sequencing is essentially just read technology, so the tools that are required to read DNA. I had no clue what that was. I visited him in his garage because I was doing some angel investing at the time. He explained it to me. He literally had a prototype on his washing machine. I said, well, yeah, what do you need? Well, I need some money. Do you have a business plan? No. Do you have a team? No. Do you have a pitch for this? No. So I said, okay, well, let me help you. And I put some work into it, about 6 weeks. We founded the company together, and we went on to develop this technology. And at the core, what it is it's a semiconductor chip that has, kind of like a camera sensor array. It has 8 million sensors. And on top of each of these sensors is a little synthetic biology micro machine that we synthetically designed at the genomic level. And we grow these little machines up in bacteria. And they can generate an electrical signal when they process DNA that the chip can read. So we developed that. We had a really hard time raising money for this company. We went to about 100 VCs and pitched it. Nobody wanted to hear anything about it. It was right after the financial crisis as well. And we went out of business, almost went out of business a couple of times. were on the verge of bankruptcy many times. I remember one instance, I had one investor left in New York that had expressed some interest, and I called him and I said, Matt, here, are you going to put money in? We really need it now. And he goes, you know, we're not really in the business of doing private companies. And I said, Matt, if you're going to tell me you're not investing, we're going to hang up right now. I'm going to fly out to New York on the red eye. I'll be in your office tomorrow morning, 10 a.m. And you tell it to my face. So I knocked to him. I flew out, and then I went to Central Park, the building where the Apple store is. He's in that building on the 50th floor. I show up there at the reception desk, and the secretary says, well, I'm here to see Matt. Does he know you're here? I don't think so. I hope he's around. But so he sees me, he says, you're really here. I pitched to him why he should do the deal. And he tells me, well, I can't decide that. Only the head of this multi-billion-dollar hedge fund can decide that personally. I say, well, bring him in, okay? So they brought him in. He gave me 5 minutes. Ultimately, it turned out to be an hour-long conversation. And he said, okay, how much money do you need? I said, $5 million. He said, okay, we'll do the deal. And he got his money back 6 times 6 months later. So 6 months later, we sold the company for $350 million to Roche. But the lesson learned there, I always say the trick is not to die, right? There are so many odds against you, and so many times you could legitimately give up, right? But if you do, you're out of the game, right? But if you find a way to keep going, then that's, overcome that, and that's when you get the chance to ultimately bring it to a successful exit.
Has anyone actually started a company as a result of a meeting in Starbucks? I know it's kind of like a real thing that people believe happens, and it did, but who else has started a company in Starbucks? There should be a society for startups started in Starbucks. That'd be that's quite good. I should get into marketing. Maybe not. Listen, Stefan, talking of beating the odds, you've seen a lot of entrepreneurs. You talk and you invest at a very early stage. You support companies that have founders much like you that have great ambition, great vision, sometimes have absolutely no background in the thing that they're doing, but they have this entrepreneurial spirit, and a lot of them are very deeply technical. What is it that your advice would be to those people? I mean, the concept of obviously having enough capital and fighting for that is very important, but obviously it's more than that. There is something that is natural within your spirit. What is it that we can learn from an entrepreneurial side that helps us not to die, but also helps us to be really successful?
Yeah, the companies I invest in are people I like and ideas that excite me. And I often see these business plans that lack key elements, right? There's something there that's not figured out, right? And VCs typically want to check the boxes and say, we need these 5 things. I'm much more willing to go in when 1 or 2 of these is missing, which basically means that more times than not, they don't work out, right? But entrepreneurs tend to, if they have the right attitude, they can figure out what's missing and find solutions for that. Hire in the missing people to the team, shift the business, figure out a better revenue model. It doesn't all have to be there at the beginning. If you're willing to sort of take a risk or take a punt on these companies, then you do find the jewels out there, right? And if you kind of sort of can help advise and get over those obstacles, then I'd like to think that the few that work out pay for the ones that fail. So it's definitely not a model that I could live off. But I do think, for example, if you kind of compare California to the UK, there are more investors in California like me. There's an ecosystem of people that are kind of willing to just kind of play that game, right? And if I go to my friends and say I invested in this company, they bring some friends in, et cetera. I think London and the UK could use a bit more of that sort of attitude to say, look, I'll take a risk on that entrepreneur, I'll take a risk on that idea, even if the revenue metrics aren't there yet, even if there's something that they haven't quite answered yet.
But do you think that there is the talent and the ambition here? It's just, I know there's the appetite of risk, and people like yourself on the investment side, obviously. Oh, yeah. So what are you seeing and feeling here now? Not just obviously in an event like this, it's a very sort of compressed version of reality. But what are you seeing in the UK and Europe?
Well, I mean, the 2 most exciting technologies in the world right now, if you look at the whole genomic space, that's first of all, DNA was discovered in Cambridge, right? And the core of the technology that is the base of the Illumina system. Illumina is sort of the 500-pound gorilla or 800-pound gorilla in the space. They own sequencing. They're a $25, $30 billion market cap company. That technology was developed in the UK. It was backed originally by some UK investors, but then sold for a couple $100 million, I think 300 or 500, I don't know the exact number, to Illumina, right? That could have stayed a UK technology. That could have been developed here. There's absolutely no reason why it would have to be owned by a US company. Illumina, in fact, doesn't have anything of real value other than that sequencing technology they acquired. So I think there was a lack of, I don't want to speak for the investors and why they sold. It was probably a nice return. But if they had kept it and pushed on here, the talent, the technology is here. Same is true in AI, Google, DeepMind. A lot of that stuff comes out of Europe, but then ultimately to take it across the finish line and to take it all the way, it gets sold off into the US. It wouldn't have to be that way in my view. Mm.
Let's talk about other kinds of odds and beating them. Obviously, a subject quite close to your heart, but you've moved now, from secure systems for financial trading through to developing gene sequencing on a chip, and now the use of AI and next generation sequencing, deep molecular profiling, and high frequency biomarker stuff to help people beat the odds of cancer. Tell us a little bit about this. I've got a little picture of you and some of your current venture. Let's see if this is working. There we go. So there's you and some of your little team here. Tell us about this next thing and about your view on beating the odds in currently untreatable disease.
Yeah, so people that see me walking around with this ask what this is, and I tell them it's my Bitcoin wallet, and I'm doing some Bitcoin mining in my head. And but really what it is a device that uses electromagnetic field therapy to prevent tumor growth. And about 2 years ago, I fell off my bike. I was diagnosed with a brain tumor that had fairly poor prognosis if you treated it with a standard of care, even if you went to an institution like Stanford, where you had world-class surgeons and great sort of first-line treatment. But the standard treatment for this type of a cancer really wasn't too hopeful. But through my Genia background, I had access to a great number of experts in sort of molecular biology, human genetics, all the latest and greatest technologies that if you combine them, our feeling was that you could actually achieve much better outcomes, right? So what we did was we put together this tumor board, which most cancer patients effectively have a tumor board, they just don't know it. But it meets once or twice during the course of their disease and makes a recommendation and says, this is how we should treat this particular patient. My tumor board, we meet weekly. So we have weekly conference calls, and then once a quarter we do an offsite, and we scan the latest literature sort of globally and kind of say, look, what do we need to be doing to put together the right therapy here? And the fundamental conviction behind that model is that in order to treat something as complicated as this, you need to do it through combination therapy. There's not just one monotherapy, not just one thing that you can do to beat it. You actually have to hit it from as many different angles as possible. The problem is you don't know what it is that works, right? You don't know if you're treating it, whether you're making progress or not. So the first thing we did was I went to Stanford, and my group at Roche had acquired a technology out of Stanford that had developed a ctDNA test. So that's a circulating tumor DNA test. We acquired that for a couple $100 million to commercialize it for non-small cell lung cancer. And it can be used to detect and monitor lung cancer. But it hadn't been applied yet to a brain tumor. So I literally within the day of the diagnosis, I approached the team there. And we modified the test to turn it into a monitoring tool for a brain tumor burden. And I sponsored a trial with 10 patients at Stanford to do that. So there's now 10 patients on this program. And we can do monthly, even weekly blood draws and we can see what the tumor burden is. And right now, within the limits of detection, so we can't see anything. It doesn't mean that there's nothing left, but it means that there's very little to nothing left. But what we do know, we have a sort of 10 to 12-month head warning. If we do start to see signal, we know that we need to change something in our regime. And for these other patients, what we see is, well, if the tumor markers are going up, something in that combination isn't working. If there's steady, well, that's not going to kill you because it's not the tumor you have that kills you, it's the tumor you're going to have. Or it's going down, right, and you know you're doing the right thing. So that's a completely different approach to cancer treatment. Some people would say it's non-scientific. It's more an engineering-based approach, right? Let's try something, see if it works. If it doesn't work, let's tweak it. And what you get is, instead of an average patient, 1 or 2 shots on goal, you get put on standard of therapy. And if that doesn't work, if you're lucky, you get put on a trial. And if you're really lucky, you get put on a second trial. In this model, you've got 10 or 20 shots on goal, where you can constantly sort of tweak your approach. And I can tell you a little bit about the types of things they're doing. They're actually quite mind-boggling, right? But all of them would be almost impossible to manage if we didn't have this feedback mechanism and the diagnostics around it.
I think that's the key difference is instead of having one diagnosis, which is usually as a result of a person looking under a microscope and then a couple of other things you learn about the tumor genetically, this is understanding deeply what it is and then tracking how it's changing and then addressing that in real time. It's a real kind of example of engineering and adaptation. And it's also great that you're trying to get that out so other people can more widely get access to this more economically. We are going to talk more about that in the next panel, which is about AI and cancer. But before we end, I just wanted to sort of ask if there's any. We've got probably one question in the audience that we can have. Has anyone got any questions at all for Stefan before we roll into the next session? There's one over here. Were you the chap that got something that started a startup in Starbucks? I saw. No, it wasn't. It was next to you, I think. No. Please.
Within your scheme, is there any use for circulating tumor cells?
The question was, in the system, in this scheme of adaptive treatment, is there any room for circulating tumor cells rather than circulating tumor DNA?
So that's a question of sort of what type of diagnostic to use. And the short answer is yes. The more you look at, you can look at proteomics, RNA, various biomarkers. What you really want is you want to be able to see if your therapy is having an effect. And the more we can gather, the better. It's a question of cost right now. Some of these things are hugely expensive. But what's more important is once you have that feedback, what do you do about it, right? And part of what we did was we developed personalized vaccines using sort of immunotherapy approaches that weren't available in the US. I had various sort of scientific partners come up with recommendations for these vaccines. We designed the software. I had to go find a manufacturer to make them for me. I had to go find a doctor willing to administer them. Right now I have to find a way to smuggle them out of the country and into the US because the FDA tells me I'm not allowed to do these things, which is another reason why I'm actually quite happy that blockchain technology is going to make sort of the government's ability to intervene in our lives less effective. This is clearly an area where I think the patient should be able to decide what they do, right? But what we're doing, and there is right now set up a company called Navio. Jack came up with the acronym, and Jack, by the way, is one of the guys who's been helping me. I think he took the picture. Oh, no, you are in there.
Special selfie.
He's on the tumor board. He came up with the name Navigating Individual Options in Oncology. So what we did here for me is hugely complicated, but it doesn't have to be that way. It doesn't have to be as complicated. It doesn't have to be that expensive. It is something that can be commercialized and operationalized. Unfortunately, probably at the high end first, but the more patients we get on there, the more we can bring the sequencing costs down, the more we can automate some of the advice and decision making and take this from something that is available to sort of high net worth patients to a much broader audience and ultimately help make it standard of care. So that's our goal with this new company, Navio.
Well, we're going to talk a bit more about that in a minute. I try to think of a phrase that encapsulated my view of Stefan, and I think it's this: be dangerous, because the world is a very careful place. Thank you very much, Stefan.
Thank you.